Music theory is not a bag of rules. It is a set of maps for predicting what a piece of music is likely to do next. In this video, we will use theory for analysis. That means we will learn the concepts, but we will constantly test them on instruments. Guitar gives us shapes and fretboard patterns. Piano gives us a clear picture of intervals and voice leading. Bass tells us where the harmony stands. The voice tells us which scale degrees feel stable, tense, or resolved. The goal is practical. When you hear an arbitrary song, you should be able to form a good hypothesis about the key, the meter, the chord progression, and the next likely chord. Start with sound. A musical pitch is a vibration with a frequency. If one sound vibrates twice as fast as another, the ear hears an octave. That is the ratio 2 to 1. If one sound relates by 3 to 2, the ear hears something like a perfect fifth. These simple ratios are not the whole story, but they explain why some intervals feel unusually stable. Their wave peaks line up often. Western equal temperament makes a compromise. The octave is divided into 12 equal steps, and each semitone multiplies frequency by the 12th root of 2. Mathematically, note n has frequency f0 times 2 to the n over 12. This gives us one keyboard grid that can transpose into every key. The trade-off is that many intervals are slightly adjusted away from pure acoustic ratios. An interval is the distance between two notes. Minor thirds, major thirds, fourths, fifths, sixths, sevenths, and octaves are the vocabulary of melody and harmony. Chord quality comes from intervals. A major triad stacks a major third and a minor third. A minor triad stacks a minor third and a major third. A dominant seventh adds a tense minor seventh above the root. Now build scales. A major scale follows the step pattern whole, whole, half, whole, 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 half. In C major, that gives C, D, E, F, G, A, B, and C. The important part is not the note names. The important part is the scale degrees. Degree 1 feels like home. Degree 5 points strongly back home. Degree 7 pulls upward. Degree 4 often wants to fall to 3. From the major scale, we get 7 default triads. In C major, they are C major, D minor, E minor, F major, G major, A minor, and B diminished. In Roman numerals, that is 1, 2 minor, 3 minor, 4, 5, 6 minor, and 7 diminished. These are the first suspects when you analyze a song in a major key. The circle of fifths explains why some keys and chords are close neighbors. Move by perfect fifth, and you change only one scale degree in the key signature. C and G share 6 of 7 notes. C and F also share 6 of 7 notes. This is why progressions by fifth feel natural, and why dominant to tonic feels so strong. Functional harmony groups chords by what they do. Tonic chords feel stable, 1 and often 6 minor. Predominant chords prepare motion, 2 minor and 4. Dominant chords create tension, 5 and 7 diminished. A very common grammar is tonic, predominant, dominant, tonic. In C, that could be C, F, G, C, or C, D minor, G7, C. This is not a law of nature. It is a style convention with acoustic support and historical reinforcement. European tonal music made this grammar very explicit, and popular music inherited parts of it, changed parts of it, and mixed it with blues, modal, folk, jazz, electronic, and global traditions. Voice leading asks a different question. How far does each note move from one chord to the next? Smooth progressions often keep common tones and move other voices by small steps. A C chord has C, E, and G. A G7 chord has G, B, D, and F. The G can stay. The E can move to F. The C can move to B. Those tiny movements make the change sound connected. Useful mathematical model is a cost function. Add the absolute semitone movement for every voice. Lower cost often sounds smoother. This is not a proof of beauty, but it gives us a measurable reason why some chord transitions feel easy under the fingers and easy in the ear. Harmony also happens in time. Chords often change on strong beats, at bar lines, or at phrase boundaries. In 4/4 time, beat 1 is usually strongest, beat 3 is secondary, and beats 2 and 4 often carry backbeat energy. If a chord changes every 4 beats, start listening at beat 1. If it changes twice per bar, check beats 1 and 3. Form makes prediction easier. A verse often repeats. A chorus often repeats even more strongly. Once you have one pass through a section, your best prediction for the next pass is the same progression, with small variations. Music is full of repetition, contrast, and return. Now apply this on guitar. First listen for the bass note. Then try the common shapes in the likely key: 1, 4, 5, and 6 minor. In C major, those are C, F, G, and A minor. On guitar, you can move between open chords, bare chords, and power chord shapes. The shape gives you speed. The theory tells you which shapes to try first. On piano, spread the chord under your fingers. Play C, E, and G for C major. Move to F, A, and C for F major. Move to G, B, D, and F for G7. Piano makes the interval structure visible. If a chord sounds wrong, move one note at a time and listen for the nearest correction. Bass is the harmony's anchor. If the bass plays G while the rest of the band contains B or F, you should suspect a dominant chord. If the bass plays A and the key is C major, A minor is a strong candidate. Inversions matter. A C chord over E in the bass still belongs to C harmony, but it creates a different pull. Vocals are just as useful. The melody often emphasizes chord tones on strong beats. If the singer lands on E over a C bass, C major is likely. If the singer leans on F over a G bass, G7 is likely. If a vocal note feels tense and then resolves, name the tension as a scale degree. Here is the practical workflow. First, find the tonal center by listening for home. Second, mark the meter and section boundaries. Third, test the diatonic chords in the key. Fourth, use bass and melody to confirm or reject each chord. Fifth, explain exceptions. Borrowed chords, secondary dominance, modal mixture, blues notes, or chromatic approach chords. Let us make that workflow more concrete. To find home, do not start by naming every chord. Start by humming the note that feels finished. Pause the song, hum the ending note, and then find it on guitar or piano. If several notes seem possible, listen to the bass at the end of a phrase. Tonal music often confirms home at phrase endings, cadences, or chorus arrivals. Then ask whether the song is major, minor, modal, or blues-based. Major often centers on one with a bright third. Natural minor centers on one minor and often uses flat 6 and flat 7. Dorian minor has a raised 6, so it feels minor but less stark. Mixolydian has a flat 7 over a major tonic, which is common in rock, folk, funk, and blues-influenced music. Minor keys deserve their own warning. The natural minor scale gives I to diminished, flat A3, IV, V, flat VI, and flat VI. But tonal minor often raises scale degree 7 to create a stronger dominant. That means the V chord in A minor is often E major or E7, not E minor. If you hear G sharp in an A minor song, the song is probably borrowing from harmonic minor to point back to A. Seventh chords and extensions add color without changing the basic workflow. A triad tells you root, third, and fifth. A seventh tells you extra tension. A major seventh sounds stable but luminous. A minor seventh is common in pop, rock, funk, and jazz. A dominant seventh strongly wants resolution in tonal harmony, but in blues, it can sit on the tonic for a long time. Style changes the meaning of the same object. Secondary dominants are one of the most useful exceptions. A secondary dominant is a V chord that points temporarily to a chord other than the main tonic. In C major, D major is not diatonic because it contains F sharp. But D major is V of G. So if a progression goes C, D, G, C, the D chord is not random. It is a spotlight aimed at G. Borrowed chords are another common source of surprise. In a major key, composers and songwriters often borrow from the parallel minor. In C major, E flat, A flat, B flat, and F minor can come from C minor. These chords can sound cinematic, nostalgic, heavy, or dramatic. The theory name is modal mixture, but the practical ear training move is simple. When a chord is outside the key, ask whether it comes from the parallel minor. Chromatic approach chords can be even more direct. Sometimes a chord is chosen because its notes slide by half step into the next chord. A flat major can slide into G. D flat 7 can slide into C. This is less about belonging to the key and more about motion. On piano, play the suspicious chord, then move every finger by the shortest path to the resolution. If the motion feels inevitable, voice leading may be the explanation. Blues harmony breaks many beginner rules in productive ways. A blues song in A may use A7, D7, and E7. Classical functional harmony would call a 7 a dominant that should resolve to D. But in blues, dominant 7th color can live on the tonic. The flat third can rub against the major third. Prediction here comes from form and style. 12-bar blues is a stronger map than a strict major scale chord table. Modal loops also change the game. A song might sit on D minor to G for a long time and feel like D Dorian, not C major. The notes may be the same as C major, but the center is different. That is why tonal center matters before chord labeling. The same pitch collection can mean different things depending on where the music rests. Now connect this to practice. On guitar, use movable shapes to test hypotheses quickly. If you think the song is in G major, try G, C, D, and E minor first. If the chord sounds close, but not quite right, change the third. Major to minor is often one finger moving one fret. If a power chord works, but the full chord does not, the song may be avoiding thirds, or the recording may have distortion that blurs quality. On piano, practice triads and inversions. Root position C is C, E, G. First inversion is E, G, C. Second inversion is G, C, E. Inversions are not separate chords. They are the same chord with a different bass or spacing. When you analyze a recording, the bass might play E while the harmony is still C. That does not automatically mean E minor. Check the upper notes. Bass practice is about roots and tendencies. Write a simple chart with one chord per bar, then play only the roots. If the bass line sounds like the song's skeleton, your chord guesses are probably close. Then add fifths, approach notes, and passing tones. Bass players often connect chords melodically, so not every bass note is a root. Strong beats matter. Vocal practice is about scale degrees. Sing 1, 3, 5 over the tonic. Then sing 2 and feel it want to move. Sing 4 and let it fall to 3. Sing 7 and let it rise to 1. When a melody note feels like it demands resolution, name it as a scale degree before naming the chord. That trains your ear to hear function, not only absolute pitch. For an arbitrary song, your first chart should be humble. Use question marks. Write possible Roman numerals. Mark where the bass is clear and where it is hidden. Mark where a chord could be an inversion. Then test with an instrument. The best analysis is not the one with the fanciest names. It is the one that predicts the next phrase and survives contact with the recording. There is also a scientific reason this works. Listeners learn probabilities from the music they hear. If you have heard thousands of songs where V moves to I, your brain expects that resolution. If you listen to jazz, gospel, metal, EDM, flamenco, or Indian classical music, your expectation model changes. Music theory gives explicit names to patterns that listening has already made partly implicit. So when we say a progression is likely, we are combining several kinds of evidence. Acoustic stability, learned style, short-term repetition, phrase position, bass motion, melodic emphasis, and physical ease on instruments. None of these alone proves the answer. Together they make a strong prediction. Exercise 1. Suppose you hear C, then G, then A minor, and you need the fourth chord. In C major, that is 1, 5, 6 minor, and the most common completion is 4. F, try it on guitar. Try it on piano. Then sing A to C above the F chord, and notice how stable it feels. Exercise 2. Suppose the progression is C, E flat, F, G. E flat is not diatonic to C major, but it can be borrowed from C minor, where E flat is the flat third. In Roman numerals, that is flat 3. This is modal mixture. The borrowed chord adds color while the progression still returns to the dominant and tonic world of C. Arguments from mathematics help us with ratios, equal temperament, interval distance, and voice leading cost. Arguments from research in music cognition help us with tonal hierarchy, expectation, memory, and statistical learning. But analysis should stay humble. A chord prediction is a probability, not a verdict. What have we learned? Pitch comes from frequency. Intervals create chord quality. Scales create keys. Keys create diatonic chords. Functions describe tension and release. Rhythm and form tell us when changes are likely. Instruments let us test the theory immediately. What did we skip? We only touched modal jazz, counterpoint, Schenkerian analysis, set theory, orchestration, microtonality, detailed acoustics, deep audio signal processing, and machine learning for chord recognition. Those are rich subjects for later videos. For now, the working rule is simple. Listen for home, count the time, test the likely chords, Follow the bass, follow the melody, and choose the explanation that predicts the next moment with the fewest surprises.